Hey there, Monty here with HKN, here to solve another linear controls problem. For this question, we're asked to find the complete state variable description. Basically, we want to find this. So the first thing I'll do in this problem is what exactly are our state variables? Our state variables are anything that have derivatives in them. Those will be our state variables. So if we remember, yc equals c dv dt, and vl equals l di dt. When we do state variable diagrams, or when we do state variable models, we'll see this more as IC equals C V dot. The dot is the same as the derivative, so we'll also have IL equals, DL equals LI dot. So we can see we got three possible state variables. And our Q is given to us right here. So we kind of have a rough idea of what we're looking for. So first thing I like to do when tackling this problem is just do basic KVL and KCL so that I have some equations to go off of. So KVL I'll do this loop first. So I'll say negative VG plus VCY plus VL plus VR equals 0. And then for this loop, we also know that VR equals VC2. These two units are in parallel, so like this is going to be a good substitution for later. So now let me do KCL. So it looks like IL is equal to I2 plus I3. And that's this going this way and that way. They'll both equal each other. So now I have a good basis to start. So first thing I see here is that this VL matches kind of what we have here. So let me rewrite this as negative VG plus VC1 plus LI dot. And then we know that VR is VC2 plus VC2 is 0. So cool. We found one that we wanted. So for another one for us, let's see. So we know with KCL that I2 is I2 equals IC2. So we can replace that. And then I3, I think we'll just do Ohm's law for I3. So moving forward, let me see, what else can we get from this? So with this, we know that IL equals IC2 plus IR. So how do we find this IR? Well, what is the current going through the resistor? So E equals IR. And we know the voltage across the resistor is VC2. So VC2 over R equals I3. So let's throw that in there. Plus VC2 over R. Here we've got another example. We've got another state variable that we found because we know that this is going to become IL equals C VC2 dot. Let me get that out there. Plus VC2 over R. So cool. Now we've got our second. So now we've got one last state variable. We found this one, and we've got this one. Now we need to find this one. So because these two are in series, we can say that IC1 equals IL. Rewriting it, we can do CV dot C1 equals IL. And now we have our third state variable that we found. So let's go ahead and, let me go ahead and just reorganize things so it's easy to see. So we want first our VC1. So rearranging this, we can move the C underneath it. So V dot C1 equals IL over C. And then let's look for our VC2, which was this one. Let's go ahead and rearrange these things. And so let's move IL minus VC2 over R equals C VC2 dot. Let's go ahead and divide it by C. IL over C minus VC2 over RC equals VC2 dot. So we gotta write this here. VC2 dot equals IL over C. This is C2. C2. And VC1 was C1. Minus VC2 over R C2. So now we've got our second part of this. Now let's look for our IL. So this one. We can rearrange it so that I'm going to move this. Yeah, let's just make it a negative. Negative L I dot equals negative VG plus VC1 plus VC2. Cool. We can now I dot equals VG over L, excuse me, minus VC1 over L minus VC2 over L. And that is our third equation for it. So I dot L equals, I'm going to write the VG last. Negative VC1 over L minus VC2 over L plus VG over L. Cool. So we've got our three equations, and we can start to put them in the matrix form that we're after. So go down. VC1 dot VC2 dot IL dot equals, so we want to keep our matrix a little organized because we know this will be VC1, VC2, IL. So for VC1, we only have IL over C1. So we're going to have a 0 and a 0. This is going to be 1 over C1. For VC2, we've got VC2 and IL, so there's no VC1. For VC2, it's going to be negative 1 over RC2. And for IL, it's going to be 1 over C2. Perfect. And then for our last one, our IL, we have, for VC1, we have negative 1 over L. For VC2, we have negative 1 over L again. And then we have no IL, so it's 0. But we do have this, which is going to be part of our forcing function. So let me go ahead and VJ. So because we only have that at the bottom, it's going to be 0 for VC1, 0 for VC2, and 1 over L for VC3. Cool. So our Y is our voltage across our resistor, which is this, which we know is this. So let's go ahead and write that. So Y equals VC1, VC2, IL. And since the resistor only equals So resistor equals VC2, we're going to have a matrix of 0, 1, 0. And because there's no forcing function at the end, G. So this is our matrix A, this is our matrix B, matrix C, this is our matrix D. All right, hopefully that helped. Thanks for watching.